Now, when an exam question talks about proportionality, my recommendation is that you have in mind two graphs and two rules. So for direct proportion, we should always have in mind that the graph goes through the origin 0, is straight line, and it's always got the relationship y equals kx. Very similar to the straight line equation y equals mx, k being the proportionality constant, the gradient of the line. So y and x. If it was inverse proportion, then inverse implies that as one variable goes up, the other goes down. So the graphs of inverse proportion should be something similar to this. And again, y and x, and the relationship between the two variables is y equals k over x. So times in k for direct, dividing by x for inverse. Once we've got those two kind of patterns in mind, then we look at the questions themselves, and if they give us different letters to y and x, then of course we can change them. But in this particular case, they have kept it as y and x, so we follow through. It's direct proportion, so we know the relationship is going to be y equals k times something. Well, it's not just x, it's talking about the square of x, so we have to be careful that we write down x squared. We can then rearrange this to get the k value, the proportionality constant. So k equals the y number divided by the square of x. So they told us, as they always do in these kind of questions, that the y number was 25 and the x number was 4. So 25 over 16. We should then, because the question said find an expression for y in terms of x, we should remember that the last thing we do at this first stage of this question is we always put the k number back into the original format, the original relationship. So we can now see that y equals 25 sixteenths of x squared. So that's the answer for A. For part B, now we've got our rule that connects these two variables. So we've got y equals 25 sixteenths of x squared. We can then put the x value in. So we've got y equals 25 sixteenths times, well, 2 squared is 4. Then we should recognise that 4 and 16 actually divide into each other. So 4 divided by 4 is 1, 16 divided by 4 is that. So the y value is actually 25 quarters, which is an improper fraction. We really ought to change it into a proper mixed number, so 6 1/4. For part C, it wanted you to find the x value when y is 9. So again, we're going to use the rule from part A. This time y is worth 9. We know the relationship has 25 and 16 times the x squared value. Well, we're trying to find x, so we have to multiply through. So x squared divided by 16 comes across as times, so that's going to be 9 times 16. And then this was timesing over here, so over the other side it's going to be divide. Now we know the square answer, so when we want the x number, we're going to have to square root. So 9 times 16 over 25. Now from our rules of surds with square roots, we can just rearrange all of this into the square root of 9 times the square root of 16, all divided by the square root of 25. Well, square root of 9 is 3, 16 square root is 4, 25 square root is 5, so this becomes 12 over 5, which again we should cancel down to a mixed number. So 5s and 12 is 2, 2 5s are 10, 2 remainder, so 2 and 2/5. Now the second question, as an example, talks about inverse proportional. So again, we look at the two rules we have for these proportionality relationships. This time we're using the inverse one. So, but this time it's got p and m, so instead of using y and x, we write p equals, it's inversely proportional to just m, so it's going to be k over m. So our k value, when we rearrange this, divided by m comes across as times, so our k value is going to be p times m, so k is going to be 9 times 48. 9 times 48, or 9 40s is 360, 9 8s is 72, so 432. Again, we find the k number to put it back into the original relationship so that we can get the actual formula that connects p and m. So we've got 432 over the m value. The question asked us to find the value of p when m is 12. So we basically now know the rule, and with these questions of proportionality you always find a rule and then use the rule with the numbers they tell you to find the missing numbers. So the p-value is going to be 432 divided by 12. Well, simplify fractions down. If you're not happy with dividing by 12, both of these numbers are even, so we can halve them down. So 216 divided by 6. 216 divided by 6 goes down to 108 divided by 3. And then 3 is into 108, we should recognise is 36. So our p-value is 36. So again, when you see questions on proportionality, write down the two rules, the two connecting rules between direct and inverse, and then go through using the values they tell you. So there'll always be two values, which then allows you to calculate the k value. And then once you have the k value, put it back into the original rule to get the final relationship between the two variables they talk about. The only complication with this is sometimes they don't give you the two numbers, and they want to make it a really A-star type question, and they might say what happens to p when m doubles or something. Well, if you're not sure, then just choose a p number, double it to get the m number, put it into the normal kind of format, see what happens to get the k number, try another one, see what happens, and basically see you get the same k, or if the k changes. If the k changes, then you look at the relationship between the two. So if you're not sure, try numbers.